First of all, take the screw out all around. Okay. Alright. You have to angle that out. See how I'm angling it out on that side? And then lift up, you have to lift up the whips because they're holding it in at this point. There we go. Okay, so now we're ready to remove all the action. We don't have to remove the hammer rail and the frame, but we can remove each whip assembly individually and put it back in. And as you can see now, we have our hammer catchers where we can refelt this if we want. We can lubricate it. We can inspect the flies on the hammers. We can refelt them here. We can lubricate the top with graphite. And we can remove the entire whip assembly itself and do all the action shrinking and spring replacement. So we're going to take a break and we're going to get to that. Again, here's a good view of the felts that are just completely ruined. See, yeah, you notice how stiff they are. Look at that. Watch how slow that's going down. That action will never ever work properly without being shrunken and lubricated. So this is going to be some job.
Okay, we have this the harness from the 140B. And as you can see, this is not set up properly. This is set up as a shielded cable on the vibrato, and the vibrato leads are just taped together so that it stays on all the time. We have a set of high voltage contacts there. They're for the 120 AC, and they're just run through. The lead for the neon bulb is just leaving there. We're going to upgrade that to an LED at some point in time. And the condition of the connectors, you can see, is poor. The wires are all frayed. We want to call your attention to the other connector and show you where this is where the rubber cracked and the high voltage 120 AC short-circuited to the ground, which is the chassis, and caused a minor spark and fire. And so therefore this is not safe to use as is. And with regards to the amplifier, it has no output. We measured only 70 volts on the read bar. It should be closer to about 120, 130. The transistors that are in it are not standard. Somebody tried to do a little work on it. The transistor for the driver is not correct, and the transistors for the output are a GE equivalent. We don't know how good they are at this point in time. We also have a situation where he took a ground to an audio jack for the 110 AC. The high voltage comes in. Miraculously, the fuse is still correctly 1 amp. We were expecting something more than that. So it needs a little work, and the first thing we have to do is prop it up with a harness or something else so that we can see that we can trace it running. And if necessary, we can put an alligator clip in here just to jump start it. But the feeling I have here is that the chassis itself needs additional work, and it's also possible that a transistor or two, especially the first one with the read bar is, may not be functional. That's also indicative of a low voltage, especially if there's a short. And like I said, it's also possible this is not running right. This is the high voltage area with the capacitors and resistive divider. Usually that's about 150 to 170 out here, maybe closer to 190 depending on line voltage on the end of the diode, and then it progressively is reduced and filtered. Finally winds up on the 1 megohm resistor here through this wire right here, and that's on the jack itself going to the read bar, and then of course you have your input capacitor going to the preamp itself. There are a number of issues. We haven't checked any voltages on here to see if there's any ripple. The fact that it has little or no output and little or no read bar voltage are consistent with a defect in the chassis. Like I said, we haven't checked all the other voltages yet. But before we even do that, we need to get a good harness in here just to test with.
Alright, here we are. We've replaced one spring so far. We've shrank the pivot points, and we've added a felt on the fly. So we're going to move on to another one now. Alright, in our steps to remove the springs are surrounded by old dried glue in the little round holes at the bottom of the whip assembly. We're shooting acetone down there to break it up. This takes a good 3 to 5 applications of the acetone to really loosen that old glue up. And it's best to actually do all 3 to 5 applications as opposed to trying to rip the spring out, because if you're just going to rip the spring out, you're going to leave all that dried crusty glue in there. You want it so the spring just literally falls out. So in between us waiting for the acetone to break up the glue, we're going to be replacing the jack felts. And we removed the jack felts by squirting the old existing felts with acetone, cutting a new felt, and replacing it.